All right, in this video, we're really going to be looking at systems of inequalities. So in our last lesson, we looked at just what one linear inequality looked like. And so now we're going to be looking at a system. So remember that a system is two or more equations graphed together. So our system of inequalities is going to be two or more linear inequalities, just like we looked at in our last video, that are graphed together. So a system is always those two or more together, right? And those inequalities is kind of where we were shading part of our graph. So our solution to a system of linear inequality is going to be where the shading pieces overlap. So it's going to be our overlap shading. And we'll look at a couple of examples, okay? So when we're shading them, I like to use different colors, but it's up to you. So the first step is we always want to, again, get them in slope-intercept form. And in this case, that's been done for us. So now I can go ahead and graph those. So this top one, I'm going to do in blue. So it tells me that y is greater than negative x minus 1. So that is going to be a dotted line because it does not have that equal to, and it's going to be shaded above. So now I can go ahead and graph that y-intercept, which is at a negative 1, and I have a slope of a negative 1. So I can keep going that. So I would also use a ruler, but I don't have one on my computer. So I see I also have this dotted line, and it's shaded above that because it's going to be greater than. So I can go ahead and shade this in blue. So then I'm going to do my next line, my next inequality, in red. So again, I have a dotted line because it does not have that equal to, and now here I'm going to shade below. And again, it's already in that slope-intercept form. So I go ahead and I plot that first point at negative 5, 3, 4, 5, and I have my slope of a positive 1. And again, I have my dotted line, and I shade below this. So I would shade everything here. So I can see, and I like to use red and blue because I know that red and blue together makes purple. So I see that I have this region right here that is shaded for both of them. So both of my equations are shaded here. So this would be my solution. And I notice that both have dotted lines on each side. So that matters too. So let's look at one more example. Let's look at number 4. So I see my first one, I'm going to go ahead and do in blue again. So I have x is less than negative 4. So that kind of a line is a vertical line. When I have x equals 2 or x is less than or x is greater than, that's a vertical line at that negative 4. So I see it's going to be a dotted line because I don't have that equal to 3, 4. So I have my dotted line at x equals negative 4, and it's shaded less than that. So it's shaded below that. Okay, so my second equation, which I'm going to do in red, is not written in the right form. So I need to go ahead and do that first. So I subtract 3x. So now I have 2y is less than or equal to negative 3x minus 2. Now I divide everything by that 2. And since it's positive, my symbol stays facing the same way. So I have y is less than negative 3 halves x minus 1. So I can go ahead and graph that. So I've got my minus 1 and a negative 3 halves. So I go down 1, 2, 3, and over 2. It's negative, so it's going to be going down. I see I have this equal to, so it's going to be a solid line, and I'm going to be shading below. So everything there's red. So I notice the part that overlaps is this chunk right here. So everything that's now purple, that's going to be the solution to that system. So there's one more example I want to walk through with you, and that's this application problem at the very end. So in these application problems, we're generally, right, going to have to start by writing our own equations first. And application problems are where everyone is like, I don't like word problems, but this is where it's reality and this is where it comes to life. So the first step is we need to write our system of inequalities first, and then we can graph them. So Sarah's pet store never has more than a combined total of 16 cats and dogs. So first off, we always want to come up with our variables, right? So I'm going to have C be cat and D be dog, just so that I can keep them straight in my mind. Okay, and I'm going to go ahead and label them on my graph. So I've got my C axis. I'm going to call my X axis my C. So this will be cats and this will be dogs. Okay, so as long as I can graph it and label it, then I'm okay. So I know my first inequality is this Sarah's pet store never has more than 16. So I know if I add my cats and my dogs together, it's less than or equal to 16 because I can't have more than that. Okay, so she also never has more than 9 cats. Well, so that tells me that cats also has to be less than or equal to 9. So now I'm going to go ahead and graph those two things individually. So let's go ahead and I'll do this top one in purple. So C plus D is less than or equal to 16. So that tells me that I can use my intercepts there, right? Because we talked about we can change this to be in slope intercept form and graph it, or I can use my intercepts to graph it however I know that. But if I know that if my cats are 0, then I would have 16 dogs. So which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And if my dogs were 0, then I would have 16 cats. And I can't really draw that because of where my oh, there we go. We'll move the webcam a little bit. And so I've got 16 cats. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so again, I see I have a solid line because I have this equal to part. So I can go ahead and do that. And then I can shade below that. So I want you to think about too why this equation and why this graph does not go into the negative sides on either the x or the y-axis. So what we're really looking at here is we're dealing with cats and dogs, right? And I can't have a negative cat and I can't have a negative dog. So that's why I kind of have to live in all of these positive values. Okay, so now let's look at that second inequality. So the cats have to be less than or equal to 9. So I can find that place too. 2, 3, 4, 5, 6, 7, 8, 9. And I see I have a solid line there again. And I would shade to this side. So then I can see, and I'll use my highlighter for this one, that this is going to be my solution set for these two inequalities. Okay, so all I've taken is now I can figure out how many cats and how many dogs would fit into both of these examples and both of these limiting factors. Okay, so now that we've worked on all those, you've got several other examples to work through that I want you to do so that you can make sure that you're right on top of this. And I'll go ahead and post the examples for you. Let me know whenever you get stuck.